Hello, welcome to Techdicted. Today we're looking at automated gates, and we're just using a stepper motor and a remote to control the gate. The stepper motor, which then controls the gate. So yeah, stay tuned, have fun. Don't forget to subscribe, like, and share my content if you find it meaningful. Yeah, let's get started. Okay, so today I decided we do things a little bit different. We're starting with the code. This is the code that was used to control the automated gate. But I want us to understand the basics of programming. Though I have done a few tutorials, which I will leave a link to, but I still wanted to go through this code and explain the various things that are happening so that it's easier for you the next project, so that I just don't have to take a lot of time explaining all this. Yeah, so I think we can get started. So I started with this including. Okay, so this is a concept in C++ and C, and now in this Arduino Programming, which uses C and C++ functions and such things. So in this case, we are including two libraries. A library is just a collection of functions. I really hope you know the basics, like the basics of programming. If you don't, just look at different tutorials that I have posted before this explaining those concepts before you come to this. So the stepper.h is a header file, and also this is a header file. And then the header file, let me just show you. For example, whenever you install Arduino, it comes with a folder where everything about your Arduino is placed. Okay, so in it you will find this libraries folder. These are the libraries that I downloaded and installed myself. Okay, so I downloaded, for example, the IR remote, which we're using on this project. Okay, and it has all this, but what we are looking for is the header file. So let me just look for the header file, which will be IR remote header file. Okay, this is the CPP file and this is the header file. So the header file contains information about what is included in the C++ file. Okay, as you'll notice, we're using C++ in making libraries, so you need to be conversant with C++ and conversant with Arduino Programming, of which, if you already know C++, then Arduino Programming will become easy because it just uses functions borrowed from it. Yeah, so when you open your .header file, you will find all this. I'll just leave you a link where I got the IR remote library and also the stepper library, or I'll just show you actually how you can actually get them if they exist in Arduino software. Okay, so you need to understand and be able to read all this. So this is a class. You know how a house, I will give an example. A house, okay, you may have one blueprint or one design, but then you may build several houses with that same design, just modifying maybe little things and then using it again and again. So basically that's a class. In now programming, that's a class. So we have this, but then here we get an instance of it. It's very technical explaining all this, but I think I'll make a different tutorial explaining it further. But anyway, this is it. We've included this IR remote.h. This is the header file for this. Instead of you going through all this, you'll just look at this and then it will tell you what is in this other one. Okay, so I have included it here, both libraries. Okay, how can you include them? One way is through manage libraries, is through this. Okay, so it's done. Now we can search, for example, stepper. and then it brings the libraries that are present and that are for stepper. So you just check and see if the one you want to use exists. Mostly you will know the library you need to use. Maybe if you buy a stepper motor, the advantage of this thing is most of the code, most of the explanations, there's a really huge community on Arduino, so you will easily find all these materials, and so downloading it you will already have prior knowledge on what you're looking for. Okay, so downloading it will be fast and easy. So just be a big fan of Google and all this will be sorted out. Yeah, so you can download them from them, or you can Google them, and then you'll find maybe a Git repository. It will probably be zipped, and so you'll download it and use it. You may find documentation on it also, but also you need to understand C++ in order for you to read it. Then we go to this, defining and declaring variables. Now, in every programming language, there are variables, and in C++, or for example in this Arduino programming, we can either define or declare them. Declaring them, you have this int, maybe const. It may be a constant or a variable. A constant is a value like pi. Pi never changes, for example. So whenever you say const pi is equals to 3.47 or 3.147 or whatever, then you know it never changes. But then when we come to variables, for example, this is a variable and this is also a variable. They may change regarding or depending on different circumstances. Okay, for example, this int receiver pin 6 means in my Arduino I will use pin 6, okay, the digital pin 6 for the receiver. That's the IR receiver, but I may also choose to use any other pin, maybe inside the code or just anywhere. So what this does is make it easier. Instead of you see, I would have written here receiver. Instead of receiver, sorry, I would have written here 6. Maybe somewhere in here I would have written also 6 again and 6 again. So changing it will be a little bit technical or a little bit hard. But then when I just declare it here and initialize it with the value 6, then everywhere in my code I will have 6 as the receiver pin, and when I want to change it I will only change it here. Okay, so that's the beauty of variables. It makes it easy when adjusting code and also interacting with the code, because I know receiver is pin 6, but if I just place 6 here, it may also be hard for me to understand, or for someone else later on who's reading my code to understand it. Yeah, so then we proceed to this part. Now, I talked about classes just a few minutes before, or a minute or two. This is now an instance of a class. Okay, so in our library of the stepper motor, we have instantiated a class here, and then we have given the class a name, small underscore stepper. And then these are the parameters it takes. The small stepper, those are the parameters it takes. Let me just show you. That's like a constructor. Let's just check. Sorry. So let's go to that. That's the stepper motor. Okay, let me use the one for the receiver, because I already opened it, so it will be easier. So I already opened the receiver one. Then we've said IRS, whatever that word is. So IR receiver. Let's just look for, let me just go to the top and then start from there. Okay, so after a bit of searching, in the IR receiver.cpp, you have this class. The IR, okay, whenever this is placed, that means this is a class. Okay, now inside this class we have the parameter passed here, int receive pin. Okay, that's the receiver pin, that's the one we're placing here. Okay, so this receiver is this, and then we're passing it as a parameter for this instance that we've created. Okay, so let's just check again. Okay, So you have that. Okay, so I hope that makes sense. Now we proceed. Results is results, so you just shorten it and then give it a name. Every instance should have a name. Basics of classes, so we'll just look at classes in another tutorial and just go into the depths of classes. So this is just, all these are just classes. Then, or instances, okay? An instance of certain class or object. Yeah. Then we proceed. Now, whenever you create, let me just create for you to see. Whenever you create a new Arduino whatever program, it comes with this too. You have the void setup and the void loop. As they've said here, in the void setup you place everything that runs once. Okay, for example, setup, anything like, let's say something happens when the program is loading, something that should always be constant, things that don't change and they only run once in the code. So for example, in our code we've placed two things. We have enabled the IR receiver so that we can now start receiving, and once it's enabled, okay? So you don't need to loop through, you just need to set it up once and just that's done. Then serial.begin, I used this because I want to print different things on the serial monitor. The serial monitor is just, let me just show you, Control Shift M, okay, anyway, let me just show you from this. So tools, serial monitor, Control Shift M. I don't know why it didn't open. Oh, it's not available. Oh, I have not connected my Arduino. Let me just connect it real fast so that, okay, now my Arduino is connected, and so Control Shift M, yeah, the serial monitor opens. So this is like, let's say a debugging thing. You use it to see what's being done with your code, like, is something being done well, so it prints whatever data you want it to print. This is now the serial monitor, so every data you want it to print is printed here, and when it's printed here, then you're able to interact with your program and see what's working well and what's not, and so switch things up a bit. So that's the serial monitor. That's why I used actually the serial.begin, because we need to start it at a baud rate of 9600. Again, we will look at that deeply later on, but for now you just need to know, mostly you'll just use this. Then the loop. Now this is where the bulk of your project probably will be, because everything that is running is placed here. So this loop goes very fast. For example, if you had an LED connected, it will blink in a way that it's not blinking if you don't put a delay. So that's how fast it is. Okay, it loops really fast, faster than the human eye can notice, if I may say. So as I said earlier, the setup, we can say, or it is actually for initializing stuff. For example, if your variables need initialization, for example, this, we need to enable the receiver, we need to start or begin the serial monitor at this baud rate. Yeah, so that's the setup. Now the loop, it goes round and round. Okay, just a loop, it's just a loop, and it allows your program to change values, to change, for it to receive code and change or respond, okay, accordingly. So for example, this is now an example of how this works. Here it's looping while it's not receiving any results, well, no button is pressed. Okay, that means the IR sensor is not receiving any code from the remote. Well, that happens, what do? We loop on this first statement, we loop there until we receive results. Okay, that's the while. once we receive results, the if, okay, while loops until a certain condition is achieved. So for example, in this, it will loop as long as no results is being received from the IR. Then if there is a result that has been received, then we can do this, okay? And that's where actually our code ends. So serial.println, so this is what allows us to print to the serial monitor. That's why we initialized the serial here. So now we can print to the serial monitor the value we receive, okay? Results.value. This you get from reading the library and understanding how it works. Or online, just look for materials, and then it's like they orient you to what the a certain library does. For example, I will leave links first to this code and also to the libraries and anything else that may be resourceful, to the Arduino where you can download Arduino, that's the arduino.cc, and anything else that will be helpful, just check the description. So once we have printed the value that has been received on the serial monitor, let me just demonstrate that. I will be pressing the button, so you will be seeing different values being printed on the serial monitor. So let me press, you see? So depending on a button I press, something different is printed. Oh, okay. I am trying not to press the buttons or the buttons for the code that starts the motor moving. That's why, yeah. So these are the different values. Now, how I selected these two, I just pressed the, let's say, the next and the previous buttons and checked the values they bring. Then once a value is selected, I switch. Okay, this is also, it's also like the if statement, so you could actually use the if. So the switch allows us to switch between cases, which is basically variables. So we have this and this. Okay, so this value we are switching if the value given here is equal to this value. Shit. Okay, I hope I have not changed anything. Okay, so if the value given here, the results.value, which is actually being printed on this, which is actually being printed here, is equal to this, then we switch and go into this, okay, and now execute the code in it. If the value is equal to this, execute the code in it, okay. So that's basically what we are doing. So we start here. So assuming we have clicked a button and it has brought us here, so we execute this code, and that is, we set the speed of the stepper. Okay, we had initialized, or we had instantiated the stepper to be small stepper with this. Then small stepper dot set speed. Now the dot is used when we are now getting functions from the library. Okay, so when you get a function from a library, you can use the class dot function. So it's the class instance or the object instance dot the function. So in this case, the function is set speed, and it has a parameter of the speed. Okay, the speed at which you want the stepper to move. This also depends on your you will just check the library and also the speed. Okay, for example, this max speed is 700, but depending on the different libraries you use, it may be different. Steps to take is equals to 24, 2048. Okay, here we defined steps as 32. This is the number of steps per revolution. So remember, this is a motor, that's why we have these terms. for a different thing, the terms will be different, the things will be different. So for this case, the steps are 32. The steps may also be different. Okay, you're the one who's setting it, so you set it differently. For me, it's 32. Okay, that's the number of revolutions. And steps to take is 2048. Now, this may be negative or positive. Now, when checking the stepper, there's the stepper library. You can just check it on the Arduino CC website. This is where you just read about these things. You don't need to have them in mind all through. You just read them when you need them. What was I saying? We were talking about, let me just check. We were talking about steps to take. So we go to this and check this. Okay, so this is the Arduino CC reference stepper constructor. I'll just send you the link to it. Okay, a constructor is a function that's run whenever the class, okay, whenever the class is, let's say the class is instantiated. So a constructor, the functions in the constructor must always be stated, or must always be defined when you're instantiating the class. That's why in the stepper, small stepper, we had brackets, then we had the steps, then we had the pins. Okay, now here, steps, this is what I'm looking for. Actually, here it is. I don't know why I'm going too far. But anyway, this is you will have to read this information. But basically, it's just the steps. And then if it's positive, okay, the number of steps to turn the motor. Positive to turn one direction, negative to the other direction. So that's how you understand these things. You just come, read about them. So then we proceed to the next, delay. This is an Arduino thing. It's not about the stepper or the IR. The delay allows, it's like a rest period before it breaks. It's how do I explain this? Let's say I want an LED to blink, for example. As I said before, if I just place the LED there and I just make the pin high throughout, if I just place, like, let's say an LED and place the pin high, it will be on throughout. But if I want it to blink, I will place it high, then place it, then have a delay, then place it low. Okay, so it's high, delay, so it's staying high during that period. Then executes the next command, which is low, then delay, so it's staying low for this period that's being delayed. Okay, yeah, so that's basically the delay. So then we break. Break now removes us from all this. So now we go here, wait for another value. Okay, so it keeps running this command, it keeps running this in a loop. Okay, when it receives another command, it comes back again, it starts over. That's the whole point of the loop. Okay, so that's it for this tutorial. I just wanted to explain this code a little bit. I hope I have explained just something. I know I have not gone into the depths, but it's because I just wanted to like highlight. Then probably I'll just do a whole tutorial on Arduino and programming. But you can also check my programming tutorials, because I have, at least I have explained some concepts, basic concepts of programming in other tutorials, and I think you may find them meaningful before you actually even think of this, starting the coding process and all this. Yeah, so that's it from this. Let's now check how this code was running in my automated gate. Yeah, that's the final thing we're doing. So before actually we go there, there's something here. you can actually just do this and you will see what it does. But there is the upload. Now whenever you've written your code and you're satisfied with how it is, you upload it to your Arduino. Okay, you first need to ensure that the board selected is the one you're using. For me it's Arduino Uno, so it's okay. Then the port should be that port, not necessarily COM3, it may be even COM19, it doesn't really matter, but it should be in brackets Arduino Uno, and it will link to the board you're using. Yeah, so that's it. I think we can now proceed to other things.